Imagine standing on a loading dock in 1972 and hearing something that sounds less like a diesel engine and more like a fighter jet preparing for takeoff. The Detroit Diesel 8V71 didn't idle quietly in a corner. It announced itself loudly to the world. For over 40 years, this machine powered everything from Coast Guard cutters to cross-country Greyhounds, and it earned a loyal following that still hasn't faded. But behind that legendary wail was an engine fighting a war against its own heat. It dripped oil like a leaky faucet, cooked its own pistons when mistreated, and punished anyone who didn't understand its rules. Some mechanics called it the greatest diesel ever made. Others called it a ticking time bomb wrapped in cast iron. The truth, as usual, sits somewhere in between. In recent months, stories have poured in from operators, fleet mechanics, retired Navy engineers, and owner-operators who spent real time living with this engine. Their accounts don't always line up. And that's exactly what makes the 8V71 so fascinating. It was an engine that inspired loyalty and frustration, both in equal measure. So was this engine a masterpiece ahead of its time, or a fundamentally flawed design that survived on sheer stubbornness? It was a machine built for a specific world, a world of open highways, open oceans, and operators who understood that this engine played by its own rules. To find the truth, we need to go all the way back to where its story started. Most diesel engines breathe on their own. This one couldn't. So what kind of diesel needs a supercharger just to survive? When GM's Detroit diesel division rolled out the 8V71 in the late 1950s, most diesel engines on the market were slow, heavy four-strokes. They thumped along at low revolutions, producing power in a steady, predictable rhythm. Think of it like a heartbeat, one power pulse every 2 rotations of the engine. The 8V71 threw that convention out the window. It was a 2-stroke, meaning it produced a power pulse on every single rotation, twice the punches in the same amount of time. On paper, it was brilliant. In practice, it required an engineering trick that would define this engine's entire personality. Here's the thing about a 2-stroke diesel. It can't breathe on its own. A regular 4-stroke engine has a dedicated intake stroke where it naturally sucks in fresh air. The 8V71 doesn't have that. So Detroit's engineers bolted a Roots-type blower onto every single one. Think of it like a set of mechanical lungs strapped to the side of the engine. This blower constantly forced fresh air in and pushed exhaust gases out, a process called scavenging. And this wasn't optional. It wasn't a power booster you could add for fun. Without the blower, the engine literally could not run. No blower, no air. No air, no combustion. The engine would just stop. The 8V71 packed 8 cylinders into a V formation, each displacing 71 cubic inches for a combined total of 568 cubic inches. Now here's a clever part. Instead of cylinders permanently cast into the engine block, the 8V71 used what are called wet cylinder sleeves. These are removable metal tubes that slide into the block and sit completely surrounded by coolant. When a sleeve wore out after years of use, you didn't need to send the whole block to a machine shop. You just pulled the old sleeve out, dropped a new one in, and you were back in business. That kind of design saved fleet operators serious money and serious downtime. Fuel delivery was another area where Detroit kept things refreshingly simple. Most modern diesels use a shared fuel rail, basically a pressurized fuel pipe that feeds all the cylinders at once. The 8V71 didn't do that. Instead, every single cylinder had its own self-contained injector, driven mechanically by the camshaft. No shared plumbing, no complex rail system. If one injector needed work, A mechanic could swap it out in the field without touching anything else. But there was a trade-off. These injectors had to be calibrated precisely. When they wore down or fell out of adjustment, the engine would start misfiring, running rough, and losing power in a hurry. Now let's talk about how tightly this engine was built. The compression ratio, which is basically how much the engine squeezes the air before ignition, sat at 17:1 on standard models. The higher output N-series versions cranked that up to 18.7:1. To put that in perspective, a typical gasoline engine runs around 10:1, so this thing was squeezing air almost twice as hard. The bolts holding the main bearing caps were torqued to between 165 and 175 foot-pounds, and the gap between the cylinder liner and the block measured just 1.5 thousandths of an inch when new. That's thinner than a human hair. These were not the kind of tolerances that forgave sloppy maintenance. The cylinder heads were set up with one casting covering a bank of 4 cylinders, rather than a separate head on each one. That sped up some repairs, but it also meant that if one cylinder needed attention, you were pulling the head off all 4. Fair trade-off though, because the overall philosophy here was all about getting the engine fixed fast and back to work. And that philosophy paid off in a big way. Former Greyhound mechanics have talked about swapping an entire engine in under an hour. Not rebuilding it. Swapping the whole thing. Shops would keep a freshly rebuilt unit sitting on a stand, and the moment a bus rolled in with a problem, they'd crane out the old engine and drop in the replacement. By the time the bad engine was on the rebuild bench, the bus was already back on the road. In the late 50s, that was practically unheard of. The oil system used gear-driven pumps to push lubricant through filters and coolers, keeping everything inside alive, under constant high RPM stress. But even this system had weak spots. The pressure relief valves were a known trouble area. If one got stuck open, oil pressure could tank without any warning. And the bypass valves, the kind of thing that's easy to forget during a routine service, could quietly allow dirty, unfiltered oil to circulate through the engine. You wouldn't notice right away, but over thousands of hours, that contamination would eat away at bearings and journals from the inside. The cooling system pumped coolant through the block, the heads, and an oil cooler. Marine versions added raw water or seawater circuits on top of that. But here's the catch. If you didn't flush those coolant passages regularly, especially in saltwater environments, mineral scale would build up inside like plaque in an artery. That scale would block flow in specific spots, creating hidden, hot zones that could warp a cylinder head or burn a piston long before any gauge on the dashboard told you something was wrong. The electrical system was built tough. Heavy-duty starters, beefy alternators, and relays designed to handle cold weather cranking and long duty cycles. And speaking of cold weather, this is one area where the 8V71 really won people over. Operators in places like Minnesota and northern Canada consistently said this was one of the few diesels that would fire up reliably in sub-zero temperatures without needing a shot of ether. If you've ever tried to start a diesel on a -20 morning, you know how much that matters. Every system on this engine was built for continuous, heavy-duty work, and every system had a breaking point if you didn't keep up with maintenance. But before we get to those breaking points, there's something else this engine became famous for. Something you could hear long before you ever saw it. If this story got your attention, subscribe and hit the bell. We cover the real history behind the machines that built this country, and there's a lot more coming. So how does a diesel engine end up with a nickname usually reserved for rock bands? If you have ever stood anywhere near an 8V71 at full throttle, you don't need anyone to explain the nickname. This thing screamed. With a redline typically set between 2100 and 2300 RPM, it was one of the fastest revving diesels of its generation. To put that in context, most heavy-duty diesels of that era cruised at 12 or 1400 RPM. The 8V71 spun nearly twice as fast, The combination of the two-stroke firing cycle, the whine of that roots blower, and the rapid clatter of the valve train all layered on top of each other to create a sound that was part industrial, part alien. That's how it got the name Screaming Jimmy. But the nickname wasn't just about how loud it was about attitude. Most diesels of that era were low RPM torque machines. They grunted and lugged. The 8V71 didn't work that way. It came alive when you pushed it. It wanted to be revved. Keep the tachometer climbing, and it rewarded you with instant response. Let the RPMs drop, and it would let you know. That personality made it a perfect match for jobs where quick throttle response was everything. Fire trucks racing to a call, city buses pulling away from a stop, or boats that needed full power the instant the captain shoved the throttle forward. Turbocharged versions arrived later and added even more to the legend. Now, a lot of people assume the turbo replaced the blower. It didn't. Remember, that blower was the engine's lungs. What the turbocharger actually did was feed pre-compressed air into the blower, so the blower could stuff even more into the cylinders. Think of it like giving the lungs a bigger breath to work with. These turbo models usually came with beefier injectors and sometimes an aftercooler, and they made noticeably more power. The scream got sharper, the acceleration got harder, and the reputation kept growing. In an era when most diesels announced themselves with a low rumble, the Screaming Jimmy cut through the air like nothing else on the road. Truckers could identify one by ear from a quarter-mile away, and for many operators, that sound wasn't noise. It was a promise that the machine underneath them was working exactly as it should. But that promise had conditions, and when those conditions weren't met, the consequences came fast. If the 8V71 was so well designed, why did so many of them end up cracked, warped, and burned? The answer comes down to a trade-off that was baked into the design from day one. Remember, this engine fires on every single revolution. A four-stroke fires every other revolution. That means the 8V71 was generating roughly twice as much heat in the same amount of time as a four-stroke of similar size. When everything was working properly, the cooling system, the oil system, and the air scavenging from that blower, the engine handled all that extra heat just fine. But the moment any one of those systems started falling behind, temperatures would climb fast. And with the 8V71, fast meant dangerously fast. The number one killer: neglect. Skip your coolant flushes and mineral deposits would slowly clog the passages inside the block. That restricted flow to the areas that needed it most, the cylinder heads and the upper walls, where combustion heat was most intense. A thermostat that failed in the closed position could trap hot coolant in the block with nowhere to go. A plugged oil cooler would starve the bearings and piston crowns of the cooling they depended on. And because the two-stroke naturally runs hotter than a four-stroke, the window between running fine and catastrophic overheat was razor thin. But heat wasn't the only chronic complaint. Oil leaks were so persistent, they became part of the engine's personality. Mechanics had a running joke. Nobody ever drained the oil on an 8V71, because by the time service was due, half of it was already on the shop floor. Valve cover gaskets wept. Blower seals seeped. Airbox drains dribbled. Even engines and otherwise excellent mechanical condition would leave their signature on every surface beneath them. It wasn't always a warning sign. Often it was simply the reality of a two-stroke with dozens of sealing surfaces and a whole lot of internal pressure working against every one of them. Crankcase pressure was another headache that kept coming back. Here's what happens. Over time, the cylinder liners wear, and the piston rings lose their seal. When that happens, hot combustion gases sneak past the pistons and pressurize the lower part of the engine, the crankcase. That extra pressure pushes oil out through every seal and gasket it can find. Mechanics working on fleet vehicles dealt with this constantly. especially in operations where the maintenance schedule was more of a suggestion than a requirement. But here's the thing that hurt the 8V71's reputation more than anything else. People kept putting it in jobs it was never designed for. This engine was built to run at high RPM all day, under steady load. Drop the RPMs too low, let it idle for long stretches, or make it lug at walking speed, and the scavenging process falls apart. The blower can't move enough air. Heat spikes, injectors foul, cylinder heads crack. Operators who dropped it into tractors, skid steers, or other stop-and-go equipment watched it fall apart and blamed the engine. But that wasn't a flaw in the design. That was a flaw in the decision to put it there. And the sound, as iconic as it was among enthusiasts, became a genuine liability in certain industries. Long-haul drivers may have loved the scream, but municipal fleet managers and urban transit authorities did not. By the 1980s, noise complaints and operator fatigue were pushing organizations toward quieter, smoother-running alternatives. The Screaming Jimmy's greatest calling card was slowly becoming a reason to replace it. So with all of these headaches, you might wonder how this engine managed to stick around for as long as it did. The answer is simple. When you put the 8V71 where it actually belonged, it was a different machine entirely. Every weakness this engine carried had one thing in common. They only showed up when the operating conditions didn't match what Detroit's engineers had in mind. The 8V71 was purpose-built for sustained, high RPM heavy load duty, and in applications that matched that profile, it was extraordinarily difficult to beat. Marine service was perhaps its finest home. Coast Guard patrol boats, Navy support craft, commercial tugboats, and fishing vessels all ran 8V71s with enormous success. At sea, engines hold steady RPM for hours or even days at a time. There is no idling in traffic, no stop-and-go cycle to disrupt scavenging. The flat power band of the two-stroke delivered consistent output mile after nautical mile. Mechanics aboard ship appreciated the modular construction. Injectors, blower components, and even cylinder kits could be serviced without pulling the engine from its mounts. Public transit was another stronghold. Throughout the 1960s and 70s, Greyhound buses and city transit fleets across North America relied heavily on the 8V71. Drivers valued the instant throttle response. Maintenance crews appreciated how quickly major components could be accessed and replaced. The engine's ability to accelerate a loaded coach from a standing stop over and over again all day long made it ideal for route work where uptime was everything. Fire departments trusted the 8V71 for a similar reason. When a call comes in, there is no warm-up period. The engine needs to go from cold to full power in seconds, and then sustain that output for as long as the emergency lasts. The fast revving character of the two-stroke was tailor-made for that kind of demand, especially in urban departments where response runs were short, intense, and required instant acceleration through city traffic. Stationary power generation put the engine's endurance on full display. Hospitals, industrial plants, and remote construction sites used 8V71 generator sets as backup or primary power sources. Some of these units ran continuously for weeks without shutdown, accumulating thousands of hours between overhauls. When an engine is designed to run loaded at constant speed, and you give it exactly that, it rewards you with the kind of longevity that builds legends. The military found its own uses, installing the 8V71 in landing craft, mobile generators, and field support equipment. The same modularity that made it a favorite in bus depots made it invaluable in forward operating bases where a damaged engine might need a head swap in a tent with hand tools. And of course, over-the-road trucking. In the 1960s and 70s, the 8V71 pulled its share of long-haul loads across the country. Paired with the right transmission and rear-end gearing, it could grind through mountain passes and eat up interstate miles with a mechanical confidence that drivers found deeply reassuring. When these engines were healthy and properly matched to their drivetrain, they could chew through distances that would have exhausted lesser power plants. Even today, the 8V71 shows up in custom repowers and tractor pulls, chosen not just for its output but for the visceral, analog character that no electronically governed engine can replicate. But by the time those enthusiasts were falling in love with the 8V71 all over again, the commercial world had already started writing its obituary. How does an engine that conquered oceans, highways, and combat zones get pushed into retirement by a piece of legislation? It wasn't one catastrophic flaw. It was the world slowly changing around it. The EPA had started regulating heavy-duty diesel emissions as far back as the mid-1970s, but those early rules were mild enough that two-strokes could still comply. The real pressure came in the late 1980s, when significantly tighter standards took effect. By 1994, a new round of regulations hit that targeted nitrogen oxides, particulate matter, and unburned hydrocarbons hard enough that older two-stroke engines like the 8V71 simply couldn't keep up without a complete redesign. Here's the problem. The very thing that made the 8V71 powerful, that two-stroke cycle, was also what made it dirty. During scavenging, where the blower pushes fresh air in and exhaust out, a small amount of unburned fuel and oil would inevitably escape with the exhaust. That's just how two-strokes work. And the new regulations demanded electronic engine controls, exhaust gas recirculation, diesel particulate filters, and catalytic aftertreatment. The 8V71 had none of that, and there was no realistic way to bolt any of it on. You'd basically have to design a completely new engine. For fleet operators and government agencies, it came down to simple math. It was cheaper to retire the 8V71 and buy something new than to try forcing an old mechanical engine to meet rules it was never built for. Meanwhile, companies like Cummins and Caterpillar had been building four-stroke platforms with electronic fuel injection and computer-managed engine controls for years. Their engines could meet the new standards and still deliver solid power and reliability. The two-stroke, for all its strengths, was in a fight it couldn't win. Not because it wasn't good enough, but because the rules of the game had fundamentally changed. As the engine faded from new production, its reputation fractured along generational lines. Veterans who had maintained them properly and used them in the right roles remembered the 8V71 as one of the finest diesels ever produced. Younger mechanics and operators who inherited neglected examples and mismatched applications saw only the oil stains, the cracked heads, and the endless noise. Both perspectives were honest. They were just looking at different versions of the same engine. And that split in perception gave rise to a whole set of myths that still circulate today. Even today, misinformation follows the 8V71 wherever its name comes up. So let's clear a few things up. First, one of the most stubborn myths out there is that the 8V71 used dry cylinder sleeves. It did not. Never did. From the very beginning, this was a wet sleeve engine. The liners sit surrounded by coolant, sealed with O-rings. You can see this in any rebuild, it's documented in every factory service manual, and there are dozens of teardown videos online that show it plain as day. The confusion probably comes from other engine families that did use dry liners, but the 8V71 was never one of them. Second, a lot of people think the turbocharged versions fixed all the engine's problems. They didn't. Turbocharging gave it more power and better efficiency, sure, but the core requirements didn't change. Turbo 8 V71S still needed high RPM. They still suffered if you tried to lug them at low speed. They still depended on that roots blower for scavenging. The turbo made it better, but it didn't make it different. And third, people talk about the 8V71, as if it was one single engine. It wasn't. There were naturally aspirated and turbocharged versions, marine ratings and highway ratings, different injector sizes, different compression ratios, different governor settings depending on the application. An 8V71 tuned for a fishing trawler ran nothing like one setup for a Greyhound bus. Lumping them all together is how you end up with arguments where everybody's right about their engine and wrong about the platform. So what actually killed it? Not one single thing. The world just moved on. People wanted cleaner exhaust, quieter neighborhoods, and engines smart enough to diagnose their own problems through a computer port. The 8V71 couldn't do any of that. It was a purely mechanical machine, born in an era when toughness and easy field repairs mattered more than passing an emissions test or talking to a laptop. And when the rulebook changed, there was no software update that could save it. But here's what a lot of people get wrong. They see the retirement date and assume the engine must have been a failure. That completely ignores 40 years of proof that says otherwise. In the jobs it was built for, with people who understood what it needed, the 8V71 was one of the most reliable and capable diesel engines ever put into mass production. It served across a staggering range of tough applications for close to 4 decades. That's not the track record of a failed engine, but of a machine that delivered exactly what was asked of it, right up until the world stopped asking. Today, the 8V71 still lives in collector restorations, custom truck builds, tractor pulls, and vintage boats. People chase them down not just for the horsepower, but for the character. There's something special about a diesel you can tune with a screwdriver and diagnose just by listening to it. And parts, surprisingly, still available. A whole community of specialists keeps rebuilding injectors, blowers, and cylinder kits to original specs, keeping the platform alive long after the factory moved on. At diesel shows and vintage truck meets across the country, the sound of a properly tuned 8V71 at full throttle still makes people stop what they're doing and look. There is something about a mechanical engine with no computer, no sensors, and no apologies. Just iron, fuel, and fire, doing exactly what they were built to do. In a world of silent electric motors and over-the-air software updates, the Screaming Jimmy is a reminder that engineering greatness doesn't always mean being great at everything. Sometimes it means being absolutely perfect for one specific job and making zero apologies for what you are. The 8V71 did that for nearly 4 decades, and for anyone who ever worked next to one, rode behind one, or heard one screaming down the highway at 2 in the morning, that sound isn't just mechanical noise. It's a piece of history that still echoes. So here's my question. The 8V71 served in boats, buses, fire trucks, military landing craft, generators, and long-haul rigs. If you could only keep it alive in one of those jobs, which one gets to carry the Screaming Jimmy name forward? Drop your pick in the comments. And if you've got a personal story about one of these engines, whether you loved it or it drove you crazy, post it in the comments below. Thanks for watching, and I'll see you in the next one.